All right, welcome back to The Explainer. Today we're going to dig into a really cool paper that introduces a smarter, more efficient way for AI to write computer code. It's called AgentCoder, and you'll see it's all about teamwork.
So let's get right into it. We all know that large language models can do some pretty amazing things, right? But getting them to write perfect, bug-free code on the first try, that's another story. It's a huge challenge, and they often stumble, just like us.
So the real challenge for researchers, the thing they've been wrestling with, isn't just can we get an AI to spit out some code? It's can we make sure that code is actually correct and reliable? So, how have they tried to tackle this in the past? Well, the first crack at this was something called self-correction. And you can think of it like asking a student to grade their own exam. Early approaches like self-edit or Codicot had the same AI that wrote the code also write the tests for that code. And you can probably guess the problem here. It's full of blind spots because the model just doesn't know what it doesn't know.
Okay, so then things evolved. We started seeing these more complicated multi-agent systems, things like MetaGPT and ChatDev, but they kind of slammed into two big walls. First, you still had that biased feedback problem. And second, when you've got, say, 5 or even 7 different AIs all trying to talk to each other, the communication overhead just explodes. It gets super slow and really, really expensive.
Right. So to get around all that, the researchers behind this paper came up with AgentCoder. And it's this really elegant, streamlined solution that's actually inspired by how a real software development team works.
Instead of a big, complicated mess, AgentCoder uses just 3 specialists, and each one has a very specific job. You've got the programmer agent, and its job is just to write the code. Simple enough. Then you have the test designer agent. This one's job is to create a bunch of tests, basically to try and break that code. And finally, the test executor agent runs those tests and reports back to the programmer if anything fails. But the real magic, the secret sauce, is in how that test designer works.
And this quote really hits the nail on the head. The key innovation here is that the test designer is totally independent. It never even sees the code it's creating tests for. It only knows the original request. And that separation is absolutely crucial because it completely eliminates the biased feedback that just kept tripping up all those earlier systems. It forces the tests to be objective.
And you know what? The proof is in the pudding. The data absolutely backs up this design. This isn't just a cool idea. It actually works, and it works really well.
So get this, on a standard coding test called HumanEval, AgentCoder, using GPT-4 under the hood, hit an incredible 96.3% pass rate. Now, to put that into perspective, that's the percentage of coding problems it got right on the very first try. That is a huge jump in performance compared to what came before.
And when you actually compare it, head-to-head with those bigger, more complex systems, the difference is just night and day. AgentCoder's lean 3-agent team ends up writing much more accurate code than systems like MetaGPT and ChatDev, which are trying to juggle way more agents. But here's the other part of the story, and this is just as important. It does all this while being way more efficient. This chart here is showing token overhead. Think of it as the amount of computational effort the AI needs. And look at that. AgentCoder uses less than half the resources of its competitors. It's the classic work smarter, not harder scenario. You're getting better code for less cost.
Okay, so what does this all mean for the future? What's the big takeaway here? This research has some serious real-world implications, especially for anyone out there who's building these kinds of agent-based systems.
The core lesson really seems to be that smart design is way more important than just throwing more AI agents at a problem. Things like separating your coding and testing agents, using specialists instead of generalists, and building in these unbiased feedback loops, those are powerful ideas that can make just about any AI system stronger and more efficient. And that kind of leaves us with a pretty fascinating question, doesn't it? Maybe the future of building these super smart, autonomous systems isn't about creating one single giant AI brain. Maybe it's about creating these nimble, collaborative teams of specialized AIs that all work together, kind of like a great human team.
This is for entertainment purposes only.